In this video we're going to discuss CRA models for fraction addition with like denominators. So the example we're going to look at is 1/4 plus 2/4. So like denominators just means we have the same denominator, which means our whole has been broken into the same number of parts, which means that our parts are all the exact same size. Okay. So this is going to be the easier type of fraction addition, a little bit more straightforward, but I'm going to show two concrete models, two representational models, and we'll just talk about the abstract and kind of different variation of that too. So if we have 1/4, so for the circular area model, right, this is one whole. It would be 4 of these yellow pieces to make up one whole. So here we have one piece, here we have two pieces, right? That's our numerators. Our denominators, they are each 1/4 of this whole circle, so they're all the exact same size. So again, if we're adding them together, we're thinking of combining them. So then I have 3 pieces, that's my numerator. And then what is the size or the name of each of these parts? They're each 1/4 of the whole, or they are each called a fourth. So then our denominator is just going to be fourths. Okay. So that's the area model. Length model is going to be pretty similar, right? This is our whole here. And then I'm just going to start these on separate lines just so you can kind of see the two add-ins separately. All right, so we have 1/4 here. We want to add 2 more fourths to this total length. Okay, so then I have a length of 3 pieces, or again, that's the numerator, and then what's the size, the name of each of those pieces. Since they're all the same, they're all fourths, I can say that those are 3/4. Okay. So area model and length model for the concrete are fairly straightforward. Thing to really emphasize is that the reason we can just add these together is because they're all the exact same size. I can just call all of these fourths, and that's also why our denominator stays the same in this abstract model. Okay, we went from one piece to 3 pieces and we added those 2, so the numerator is going to change because the total number of parts changed, but the size of these parts did not change, which is why the denominator will stay the same. Okay, so that's some concrete models. Representational models are going to be pretty similar. Circular area model, right, where we just have one piece is red, our other piece is blue there. So 1/4 and 2/4, so there's a total, takes up a total of 3/4 of that area. And then kind of the same idea with our number line here for the length model. Okay. Another way and then obviously this is our abstract model. Another way to kind of think of this abstract model, again, our denominator is the name of the part, right? It's the size of the part, but it's also the name of each part. So another way that we can kind of think of this is 1/4 plus 2/4. Okay, so we're just changing this into a whole number addition problem. It's 1 plus 2, and we just have to keep our label. And the reason we're able to add these together, add that 1 and 2 together, is because they have the same label. Okay, because then obviously they're going to be equal to 3. 1 plus 2 is 3. But 3 what? 3 what? What's the label? What's the name of the thing that we're talking about? We're talking about fourths. So our sum will be 3/4. Okay. So again, area model, length model. Right? You can use the physical fraction, fraction circles, fraction strips for those, and then just drawing the area model and number line for the representational, and then these would both be variations of the abstract model.